In this video, I'm going to give you some tips for the post-lab assignment for Lab 2, Analgesics. In question number 2, it asks you to measure the distance to the solvent line on your TLC plate. I am going to sketch a TLC plate right here. I'm going to make it pretty simple, but on your TLC plate, you have this line that you drew where you put your initial substances. I'm just going to draw 3. And then when you were done running the TLC plate, you traced a line across the top where the solvent traveled. In question number 2, you are measuring the distance that your solvent traveled, which is from the bottom of the plate up to that solvent line. You are not measuring the distance in between the two lines. From the bottom of the plate to the top of the line, that's the number you're going to report here. Now in question number 3, you're going to be reporting the distance, the RF value for each one of the spots for each of these different substances. The RF value is calculated by dividing, spelled it wrong there, dividing the distance that the spot traveled by the total distance that the solvent traveled. So let me sketch some spots onto this plate. Here's one. My next one's going to have a couple spots on it. Going to look like, we'll say it looks like this. So if we wanted to calculate the RF value for this first substance, we would measure the distance that that spot traveled, again from the bottom of the plate, not from the line, but from the bottom of the plate, and we would go all the way to the tippy top of the spot right there. And this can be, sometimes it can be kind of hard to find where the spot ends, because sometimes these spots are kind of blurry on their edges, but do your best. And we are going to take this distance right here, that's the distance that the spot traveled, and we'll divide it by this distance right here, that's the total distance. And then we would just write that number in this box for spot number 1. Since this substance here only has one spot, we would not be reporting anything in the other boxes. For a substance that has 2 spots, like this guy right here, I would have 2 numbers to report. First, I would take the distance that this spot traveled divided by the total distance, and I'd put that into spot number 1. And then I'd take my second distance divided by the totals, put that into spot number 2. There's no rule that says whether this spot should be called spot 1 or should this spot be called spot number 1. It doesn't matter. Not at all. Do whatever makes you happy. And so you may not need all 4 boxes for all of these substances, but you have 4 boxes for each one, just in case you do. And then once you get done with that, you'll be able to compare the data from your unknown to the data for ibuprofen, caffeine, aspirin, and acetaminophen. Your unknown is a medication that has at least one of these substances in it, but it might have more than one. And so what you're going to be doing, partly you can just kind of do a visual comparison of what your TLC plate looks like. You could also do a comparison of the RF values for each one of these spots. So let me erase some of these lines here. And let's say that this was our unknown, and this was our ibuprofen, and this was our caffeine. And if this was the results that we got, we would not be able to identify our unknown at all, because the spot that we have for our unknown does not match up with either of the spots for caffeine or with the spot for ibuprofen. So we wouldn't be able to figure this one out. But let me change this spot a little bit. Let's say I'll put my spot right there. And so if this was our data, we could say that our unknown was ibuprofen, because the spot that we see for our unknown looks like what we see for ibuprofen. They don't look exactly the same, and they won't look exactly the same with your data, but they are close enough that we're able to make a good match there.